somebody was saying that there's a misconception that humans write good code.
Welcome to It's About Data, episode 59. Lena Hall joins us to discuss agentic coding in the trenches. All right, Lena, thank you for joining us here at Data Day Texas.
Thank you so much for inviting me.
Have you here. The conference is lucky to have you as a speaker as well. So
it's been a blast.
Yeah,
it's been one of the best conferences I've been at.
So tell our audience a bit about who you are. We know who you are, obviously.
Yeah, absolutely. Well, my role is a Senior Director of Developer Relations at Akamai. So I help with the developer strategy around cloud and AI. There's many exciting AI inference workloads. So I play around a lot with GPUs, open source models, on top of VMs and managed Kubernetes. So there's a lot of fascinating things we can do now with that. And I also work a lot with coding agents, with integrating LLMs into products. So that's where I spend most of my free time.
Very nice. Yeah. So you're very much on the bleeding edge, doing the latest stuff in production, which is an enviable place to be.
And
right
I think
now.
that kind of segues into the context of our discussion here, which is like as we get into more complex jobs with AI. Of course, AI have this thing called a context window, and what you were basically addressing here at the conference was getting around the limitations of the context window. In acknowledging that we're getting in more over our heads. So why don't you take it from there?
Absolutely. Yeah, context is a tricky word, like you said.
Oh gosh,
it means so many different things. And well, of course, when we work with LLMs, they need context for solving problems, whether we're dealing with AI coding agents that help us create solutions in our CLI or IDE. They need data for their context, whether we're integrating LLMs into our products. They work with our data, they work with our specifications, and they make decisions and take actions. So we started the journey with AI development just by simply, opening up our IDE, like Visual Studio Code, with GitHub Copilot, open up the chat on the side, type in a prompt, and have a conversation with our LLM, which is how most people, got started in their journey. And this is what most beginners do right now when they work with LLM. This is how we initiate the context, feed in our initial prompt, and then when the conversation ends, our context is lost. Our session ended. So as we progress in our adoption journey, we start noticing some of the failure modes of working with context.
Right.
For example, that even though we have these amazing million token context windows, not always it's beneficial to fill them up to the end, in our work. It turns out that when the context window ends up being 20 to 40% utilized, we see a drop in the result, in the quality of the results. So we invented this amazing concept as a strategic restart, which is basically when we shut down a session, we start a new one. When that happens, we realize that we need a way to keep persistent history of what we've learned, of the progress that we've made. And now we manage a lot of MD files.
And there's a precedent for it, of course. We used in the database, in the data world, long-running transactions.
Exactly, like a write-ahead commit log of everything that we're doing. So a lot of different variations of this exist, but we start with a spec, which is an MD file, where we write out stories, and we start a file called progress.md or learnings.md, where we ask our LLM to keep track of the existing progress of the implementation. And then we realized that sometimes the MD files, they also become a mess. So there's a couple of ways we can deal with that. We could try to abstract away or split our workflow into phases. So we can start with a brainstorming phase, limit the context just to that. And if we spot an error in the brainstorming phase, eliminating that error earlier in the LLM results will prevent so many errors on the implementation stage. So
So like thinking things through step by step.
Yes. And when the LLMs were super new, I remember we used to think through the solution step by step, which was our naive attempt at making this work. But no, we actually have to split the context into multiple different sessions. But now there are more advanced approaches where, okay, MD files are great, but what if we take our learnings from what we do as people? We coordinate. We use tools like Slack and email. We use issue tracking systems. So there are more things now that we can experiment with. For example, tools like Beads, which is a graph-based issue tracking system for agents. You've probably heard Gastown, which is I would say, speculation on what agentic development might look like in the next couple of months, where instead of keeping track of our progress and everything in MD files, we rely on Git-based work trees. We externalize the state. We have multiple roles for agents, like a mayor that is the main coordinator that we work with, workers, refinery that merges conflicts in the same branch. So lots of exciting things are happening in that area. And I think a lot of people also were fascinated by this notion of Ralph agent. Ralph is a character from Simpsons.
I thought that's what you were saying.
Yeah, Ralph Wiggum. Okay. So it is a very simple idea, which is a bash loop that runs until it accomplishes the task. It starts each iteration with a fresh context window, and it takes a prompt. And in a prompt, we say that take a look at our specification, pick the highest priority task, and get it done. And there's very clear acceptance criteria there. Once it's done, it starts the next iteration and goes on until it reaches either max iterations or the progress is completed. Do not use it for anything that is highly ambiguous, because it's going to create a lot of broken code.
We'll just keep going and going and going.
Exactly. Okay. It's going to request root
Unless
access.
you're trying to play an April Fool's joke.
Yeah, absolutely. So I think this is a great area to watch. But I think we're also envisioning, we're seeing a lot of alternative approaches to how we integrate LLMs into our applications, which is a different story. In coding with AI, we are the domain experts. We are software engineers who know what correct looks like. When we're integrating LLMs into products, yes, we are writing the code, we're working with AI to create the solution, but where is our SME? Where is our banking expert, health insurance expert? What most teams do right now is they rely on post-facto evals, so evaluations where once the system is running, they get these parameters like logs and do error analysis, which allows them to evaluate, is the system doing exactly what the business intended, and mark it pass or fail. But this is not great because it's post-facto, so we cannot prevent the errors from happening during the development process. But there are ways that we could make this work if we introduce the notion of including the SME into the logic formation loop. There's no tool for that, though.
Well, it's basically a human in the loop.
I would say human in the loop is when agent recognizes that a decision, that they're not able to make a decision, and they have to call a human to help us resolve it. In terms of creation of the solution, I think that where the human comes is during the definition of the context graphs and semantic layers, where there is a ton of documentation that exists now, but nothing, not 100% is documented. So when the system runs, the human will identify, oh, this is actually not documented. We have to update this in this spreadsheet or table or database. And we need to give them an opportunity to work with the LLM to make those changes in the entity definitions. And there are ways to do that, but it's technically complex.
So do you have agents set up to identify those gaps, to say, hey, I don't know what this term is, or hey, this term is somewhat ambiguous because it's defined in different ways and it's not in your semantic layer, not in your documentation?
Yeah, so I think that's one of the ways to do so.
Yeah.
I think another way is, usually what happens is when LLM is integrated into a product, there is an API call somewhere that relies on it. And then great if we have structured outputs, great if we have like retries and validation of all of that. What I've seen is during the development process, an LLM can be used to generate deterministic code to solve a specific issue. So for example, if a domain expert works with a software engineer to write detailed product requirement document, and then that could generate an executable artifact, we need to give a chance to that domain expert to dry run that functionality and talk to an LLM, to a meta LLM, to fix the underlying data layer. And then once those changes are introduced, we could approve this functionality to be added to a product that goes to production. So what we're doing is splitting planning and execution, just like we did with coding agents, but in the process of development for a specific domain product. So it's a pretty new methodology, I would say, that folks are trying out, but I've seen success with that in the highly regulated industries where they cannot afford a mistake, where a non-deterministic call might break everything.
Okay, so you got to build in this extra layer of determinism with a lot of human intervention, basically.
Yeah, and that intervention only happens, it is blocking only during the development process, but it's not blocking production because production is deterministic.
I think that's a riddle for, with AI in general, is basically trying to balance off the non-deterministic with the deterministic. And the thing is that what you don't want with the deterministic is essentially put it into like a straitjacket. But on the other hand, you don't, it's like this delicate balance between the straitjacket and go wild. And so what I would like, what I'm just wondering in general is, how do you really, determine, the right balance?
Yeah. I would start with identifying the scenario and the cost of mistake. So,
so a quantitative approach.
Yeah. So let's say with AI or without AI, can we afford a certain percentage of a mistake? And we know that with large language models, in certain cases, like 5% of error rate is very common. And if we are prepared to handle that, so if structured outputs are enough to do it, and if we're able to get through it, that's great. But in many cases, that's non-negotiable to have 99.9.
Well, obviously it's use case driven, because and I remember, during the early days when we were starting to get, basically infatuated with ChatGPT, we were looking at what types of use cases where you don't need a precise answer. In other words, you're generating marketing content versus where you need a precise answer, which probably ChatGPT is probably not the best idea, but still that same sort of idea of like, looking at through the use case.
Right. And I think that a lot of scenarios do not need precise, reliability 100% of the time. Like marketing, like productivity, I would say, great if we increase our productivity to 100%. But in the worst case, staying the same or increases only 50%. So there's a lot of those scenarios in place.
Well, and humans make mistakes too. And it's just understanding, okay, what are kind of acceptable human-like mistakes versus, withdrawing all the money in a customer's bank account is probably not acceptable.
Right, but we need to update that expression. To err is AI.
Exactly. And I think there was an interesting conversation about somebody was saying that there is a misconception that humans write good code.
Well, that's fair, although, part of what I would say with respect to code is that it took humans a long time to get into these like truly agile incremental processes with small changes committed over time with pull requests and code reviews. And it seems like we're still figuring out how to impose the same structure on coding agents, and maybe that's part of the solution, or maybe it's a different solution, I don't know.
Yeah, what I'm seeing right now in the industry is a lot of really smart engineers who worked at Bell Labs, right? Creating the Java programming language. They are all in on the idea of not reading the code, running 20, 30 parallel agents at the same time. And kind of the argument is that things are going that way, and the LLMs are getting so good that reviewing the code is not humanly possible for that amount of output. But what we do need to do is we need to have that infrastructure around it with integration tests, with type checking, with static analysis that helps us validate whether the output is reliable. Just like we don't write assembly anymore, we learn to trust it. And somehow we need to learn to trust the new way. So I'm just watching with fascination the new approaches emerging.
Well, just to wrap up, and obviously we've only just scratched the surface, but what is, let's say, a parting thought or maybe like a parting question that you would like to put to the audience that they should consider?
I would say stay curious, because in the tech industry, we've always been very opinionated. We've always been very religious about technology that we prefer or like. And what you've tried yesterday may not be true today. So if you're anti-AI, and you have tried AI 6 months ago, you're out of the loop. So I would say you need to constantly try new things, and there's just so many of them. You have to form your own opinion, not once, but you have to reevaluate it. So do not get stuck in your ways. And that, I think that's the only way to keep up.
Fast moving target. Lena, thanks for taking the time.
Thank you so much.
And look forward to continuing the discussion.
Thank you.
Thanks.